Welcome to lecture 41. In this lecture, we will be showing you another experiment with a sensor, which is a gas sensor. Okay. So, in this experiment, what we will do is that we will again read the sensor values. In this case, the sensor is the gas sensor, and depending on that, an alarm system will be activated. Okay. This is a simple experiment that we can do, but you can think of doing many more application or many more experiment with the various sensors that we have discussed in this course. So, roughly we have come to the end of the course, and this will be the final experiment with sensor. So, let me move on. Firstly, I will show you how I will be interfacing the MQ2 gas sensor to the STM32 board, and then I will demonstrate the experiment. Firstly, about the MQ2 gas sensor, it looks like somewhat like this, okay, and you can see there is a VCC, ground, analog out and a digital out. So, MQ2 gas sensor is most suited to measure the presence of the following gases. It can detect gas like methane, butane, LPG or smoke. When we say a gas sensor, generally it could be any gas sensor which could be kept in a kitchen or in any room as well. So, we are mostly concerned with the smoke that we will be sensing through this particular sensor, although it could sense many other kind of gas as well. So, the pin configuration goes like this. The first pin is the power supply voltage, which is typically 5 volt, that is VCC, then the ground connection, then there is a digital out pin. In this digital out pin, this is the digital out pin, we can get a digital value from this pin basically, and by setting the threshold value using the potentiometer. We have already seen the use of potentiometer in LCD display as well. So, here also if you want to use this digital out value, this digital value, then we have to use the potentiometer to adjust this threshold value, and then the analog output. The analog out pin we are mostly concerned with. So, this pin outputs 0 to 5 volt analog based on the intensity of the gas sensor, which will be connected to analog port, which internally will give some digital value to us. Okay. So, these are the following pins of this MQ2 gas sensor. There are certain points to be noted here, that in that MQ2 gas sensor there is a heater inside the sensor, and it requires some time to preheat after the power is applied. So, when we start the system, it might require some time to initiate or to preheat the particular sensor, so that it can work accordingly. For interfacing with the microcontroller, the analog out pin can be connected to one of the analog input pins. So, that we have already done. For most of the experiment, we have connected the analog port of any of those sensor or the signal output port of any of those sensor to the analog input port of the microcontroller. So, same way we will be doing that, and a suitable threshold can be set to trigger the alarm on detecting some gas. Now, this is something you have to think upon, like at what level you want to generally sense or want your system to get activated. Okay. Either it be an alarm system, or you can connect a GSM that will directly send a message to fire brigade. Okay. So, it depends on that particular condition, but generally the level of the smoke you can understand, you have to again calibrate, you have to do something such that smoke gets generated, and then you have to see that what value you are receiving through cool term, okay, and accordingly you write your program. So, for that reason this is very important. A suitable threshold can be set to trigger an alarm on detecting some gas. So, in this experiment what we will be doing, when there is a presence of gas, then an audible alarm will be activated. Okay. So, the MQ2 gas sensor is connected to the analog input pin A1 of STM board, and a speaker is connected to the PWM output pin D3. There are other PWM output pin as well, but we have connected it to PWM digital output pin D3. So, this is about the experiment. Let us move on. Okay. So, this is the connection diagram, which is fairly straightforward. So, if you see this analog, we are not concerned about the digital pin, we are connecting the analog out to A1, then this ground is connected, VCC is connected, and then with the speaker, the alarm system when it will get activated depending on the percentage of gas present in a room, we use this D3 pin. Okay. So, this is the simple connection diagram that is required. Now, let us look into the PWM, the embed C code basically, where recall what we have done to generate a siren like sound. We have written this particular code, my PWM dot period underscore in microsecond 3000 and the pulse width 1550 and again 3000 and 1550 and wait for some time, and again we are doing 2200 and pulse width of 100. So, basically if you see this void fire, so fire is a function that we have written, and this particular function is very similar to what we were doing for the speaker, generating a siren like sound through speaker. Okay. This is what you have to do. Prior to that, these are again straightforward thing. This is PWM out, my PWM is for connecting with the speaker, and analog in G, that is the gas sensor name we are giving G, we are connecting it to analog port A1. So, this is all about this connection, and this part of the code is for the fire alarm. Now, in the main function what we need to do is that while one, that means this will be repeated, we are reading the value of the sensor, that we are doing for most of the code. Here we are writing G dot read is X. And at this point what I expect you to do, you use some kind of serial communication method like CoolTerm or so to display this value, what value it is you are getting when there is no smoke, what value you are getting when there is little smoke, what value you are getting where there is full smoke. Okay. So, you have to understand it that you need to do this calibration for your program. Okay. So, this is printf, we are printing it out. We have seen if the value is greater than 0.30, then we are calling this alarm system. We wait for 1 second and we again set some period, and this goes on. If it is again greater than 30.30, again the alarm system will be put on. Okay. So, this is a sample code that we have written for interfacing gas sensor along with the alarm system, that is using the speaker. Okay. So, we have come to the end of lecture 41, and this actually ends formally the experiments that we have shown you in this particular course. So, now I will be showing you how I will actually demonstrate you the interfacing part with the gas sensor, which I have talked about just now. In this experiment, I will be connecting a smoke sensor along with STM board, and what this smoke sensor will do, whenever there is a smoke, whenever it senses smoke in the surrounding, it will actually alarm. It will make an alarm. You can make anything, you can make an alarm. In this experiment, I will be showing it using the speaker that we have already interfaced. But you can also do something like this. Whenever smoke is sensed, an SMS should go to the fire brigade. Okay. So, some kind of interfacing also you can do. In that interfacing, what you have to do, apart from connecting this gas sensor, you also will be requiring a GSM board. So, what that GSM board will be doing, whenever a smoke is detected, anytime it will send an SMS alert to the fire brigade. Okay. So, we can do many possible things, but here what we are doing essentially is we will be interfacing this smoke sensor, and whenever there is a smoke inside this room, specifically it should sense the smoke should come close to that sensor. That is also one criteria. Then the speaker will make a siren kind of sound. Okay. So, let us see how do I interface this gas sensor along with the speaker and with the STM board. So, this is the gas sensor. Okay. This is the gas sensor that we will be using. You can see there are 4 pins that are connected. Okay. So, what are those pins? One is AD, another is DD, another is your ground, and another is your BCC. Okay. These are the 4 pins. So, I will be connecting the ground, the BCC, and I will be taking the analog output. Okay. So, I am not concerned about the digital output, I am concerned more about the analog output. So, I will be taking the analog output and I will be connecting it to pin A1 of my STM board. Okay. Pin A1 of my STM board, the board which I will be using. Okay. So, this connection I will make, and this is the speaker. The speaker I will be connecting one to ground and another to one of the PWM port. In this case, we have used D3 port as the PWM port. Okay. So, let us first make the connection. So, first one is BCC. The next one is ground. Next one is ground, and then the last one is the analog, which I will be connecting with the A1 pin of STM. Okay. This is a simple connection with the sensor, with the smoke sensor that I have done. Okay. Now I will be connecting this speaker with D3 and one with ground, which is the 4th pin from this side. Okay. So, this is all about the connection. that we have made. Okay. The code I have already discussed with you. So, I will now dump the code. Okay. The code is already dumped. Now, I will use a matchstick. I will just glue this matchstick and use the smoke of this after it is off. Okay, so just a second, I have to okay. So, whenever it senses the smoke, the siren will be on for some time. Okay. So, I will just repeat this once more. So, it should receive a good amount of smoke, then only it will sense, and that is also true, that see, it is working. Okay, so the connection is fairly simple. We have connected the smoke sensor, we have integrated with the speaker, but we can do it with any other thing. And in a home automation system, you can always have, for security purpose, this smoke sensor integrated in your home. Okay. So, this is all about the experiment with the smoke sensor. We will move on and we will see that what all experiments we can do next.